primary objective, and the methodologies used. One of them is PCA, but it's a very specific PCA. It's known as future-oriented principal component analysis. Have applied band ratioing, and also we have applied some sort of we have applied also AGI for the validation of the study. This is the area, as I have said. The area is within the rift, and simply we have the Achaean Basin, which you can get beef, granites, and the gneisses. But on top of that, as we know, in most of our East African basin, we have the Miocene, Sin Rift, and where you can get conglomerate sand silts and stuff. Also, we have Pleistocene and we have Holocene. And as you can see within the east, where this area is located in relation to the other reef systems. So basically, this is where we are talking about, and this is our study area. In terms of methodology, as I've tried to explain, we use the satellite images. Of course, you need to have a literature review as well to understand what is going on around. I've downloaded ASTER scenes with 15 meters, 30 meters, and 90 meters resolution bands. Following the normal procedures of stacking FCC, band ratio, PCA, and also for validation we use the AGA analysis. And then we had our interpretation, which will give us a clue of how valuable this area is in terms of hydrocarbon, because you tend to need to proceed with further exploration. You need to get some sort of assurances if what I'm looking for is it available in a specific area. In terms of results, you can see we are able to map the kaolinite using the band ratioing. We are able to map the ferrous. We are able to map the carbonates, and also the last image is the combined of the three effects, which will optimize the three studied effects from each alteration. So you can see we have, in terms of selective PCA, we also had some areas which indicated the differences. Actually, we look into the differences in spectral characteristics from the ratio of the brightness to the darkness, sort of. And then we were able to map sort of similar areas. And then we did have to take the advantage of the AGI sampling now, where they did map hydrocarbons' existence based on the differences in the carbon spectrum. Therefore, you can see these areas were clearly intersecting some areas that were mapped within the satellite images. Therefore, with the areas, you can see where in relation to the geology as well, you can see they are very near to the bounding, to the main faults of the area. So we did have to optimize those areas that were intersecting the AGI, the areas that were intersecting the results of the band ratioing, the areas that were intersecting the PCA, to get the assurance that where we are mapping, at least we are getting the same results from different angles. So with the AGI, which are the real samples, they kind of giving us assurance of what is in the area, which is hydrocarbon we're looking for. The areas were also being underlain by some of the gravity maps. To your left is the AGG, and to your right is the depth map. And you can see where we map the structures is where we also have these kind of signals from all the 4 methodologies being applied. And if you see the depth of the sediments around those areas, we have a good depth of up to 4 kilometers. And that indicates you where we're seeing these alterations, the areas where we exactly, even in a geological point of view, in a structural point of view, we are trying to continue with our exploration work. Okay, jump to the conclusion. Yeah, so the conclusion of this study, as we have seen in the area of interest, has definitely demonstrated the alterations in ferrous, kaolinite, and carbonate minerals, which suggesting the presence of hydrocarbon microseepages in the basin. The prospects were found near the key structures, as we have seen, and those structures are associated with hydrocarbon generation, such as the major bounding faults and the good sediment thickness around them. Also, we have seen the validation also when aligned with all areas we were mapping, I mean the samples taken. So that is indicating us, that's the good indication of the existing working petroleum system in the ERC part. This is just part, the southern part of the block. It's just a study area, so but it is within the actual rift system. In terms of policy implication, we believe our energy policy aims to ensure we have reliable, affordable, and sustainable energy for national development. But also, we need to attract investment in these areas of exploration, as we all know how expensive exploration is. So, when we do exploration activities, we hope once they are successful and we do it diligently, that means we will be able to enhance our national policy. I mean, we'll play part in achieving these objectives, having the reliable energy, strengthen the country energy security, also reduce the reliability to the imports. So, and when you are conducting this exploration, always you'll open up business opportunity. Could be local, could be international, could be in partnership with the local companies. So exploration, production companies, they will always conduct activities like surveys, drilling, management. You'll have constructions in terms of engineering, you'll have maintenance, you'll have service providers, and you'll have technology firms. So there will be opportunities in terms of when we're still conducting these exploration activities, and more opportunities will come when we make a discovery. Thank you very much.
Thank you. Let's clap hands for him. And we will have the questions at the end of all sessions. Let me invite our second speaker, who is Ronald Kagwa from Uganda.
Thank you, moderator. As I was earlier introduced, Ronald Kagwa, once again, is my name. I work as an exploration geologist specialist with the Uganda National Oil Company, and I'm here to present you the topic Integrated Petrophysical Analysis and Reservoir Characterization of the Kasurban Contract Area. Okay, as the slides come. The Kasroban contract area is an exploration block that is located in the northern part of the Lake Albertine Basin. And we all know that the Lake Albertine Basin is in the East African Rift System. Yeah, this area is also located north of the Ingasa exploration area, but just south of the Tilinga development area that is operated by our partners. It is about 1,285 square kilometers with 3 wells that have been previously drilled in the area. Next slide, please. The major objective of this study was to refine the petroleum potential of the contract area, but specifically, this was done by performing reservoir characterization in order to determine the sedimentology, the facies, and deposition environments of this area. And then the other way was through performing petrophysical interpretation in order to determine the reservoir petrophysical properties in the subsurface. As I earlier introduced you, that is the block as illustrated on the map. Next slide, please. Okay, under reservoir characterization, we performed the sedimentological analysis where cores were analyzed in order to determine the facies and their associations. From the facies analysis, we were in position to derive the deposition environments that then informed the kind of conceptual model that we derived in this area. Also under reservoir characterization, we performed electrofacies analysis, and these electrofacies were derived from the clusters of well logs, such as the gamma ray, the neutron porosity, and the sonic, but also making sure that our interpretation is consistent with the facies interpretation from the cores. Yes, and under petrophysical analysis, we used the well logs in order to determine the petrophysical parameters, and we used cutoffs using a deterministic approach, and hence we were in position to define the reservoir units, the net to gross, and also the pay zones of this area. Okay. All right. Under sedimentological analysis, we used Taitai 1A, which was the cored well, and the cores were studied at a scale of 1 to 50 centimeters. And the common facies in this area were found to be the gneisses, the conglomerates, gravels, sand, silts, and clays. In the environments of deposition were the alluvial fan and the fan deltas. A typical example, as illustrated, are the channelized part of the proximal alluvial fan under the alluvial fans, and also a figure 2 presenting to the subaqueous mass flow deposits as the fan delta that is composed of mostly sandstones that are fine to medium grained, and also medium to good porosity, and also locally bioturbated. As a result, a conceptual geological model in a rift setting was derived, and as we may know, geoscientists, that such a model is associated with marginal supply, which is also characterized by the alluvial fan and fan delta, and then the axial supply that is dominated by fluvial river systems and river deltas, and also the lake system, which is the depot center. And as you can see, it is clearly illustrated. The sediments are coming from the north, or could be also the south, as the axial, and then from the sides where sediments come from the sides of the basin into the depot center. Okay. And under electrofacies analysis, the facies were coded and also upscaled, but also using the results of the electrofacies from the well logs, we made sure that this is correlated to make sure that we get a perfect match. That is, the results of the fasces from the core analysis and also the electropasces analysis. And having gotten a match, we were able to extrapolate this interpretation in other uncored intervals, in other wells. That is the Karuka 1 and Karuka 2 wells. And as a result, we were in position to identify the main stratigraphic units of this area and also redefining the well tops, hence proposing a new stratigraphic scheme of this area. Next slide, please. Okay. All right. And also using the results from the different wells, having gotten the well tops, we were able to use the deterministic approach, and we used cutoffs in order to refine the reservoir units with their corresponding petrophysical parameters. And the cutoffs that we used for volume of shale, porosity, and saturation were derived from the analog fields that are very close. As you saw the other map, the development fields are just close to our block. And also those values being typical of clastic environments that we have in our area. And as you can see on that table, the reservoir sections H15, H25, and H27 appear to have high net to gross, high saturation, and also a reasonably high pay. And this is associated with Tai 1, but also moving right is the Karuka 2 and also Karuka 1. So those are the main reservoir sections of which hydrocarbons were encountered in H15 and H25 of the Tai 1. Next slide. Okay. In conclusion, the area, Kasroban contract area, is in an area that is already being developed. We have existing infrastructure and also planned infrastructure such as the access roads, the feeder pipelines, the refinery, and also a number of studies. By end of last year, we completed a number of subsurface studies. We have data, that is the 2D data that is available, and also the well data from those wells that had been drilled, core data, pressure data, but also we have planned and ongoing activities such as the reprocessing of the available 2D data is ongoing and about to be completed, and also these planned acquisition of the 150 line kilometers of 2D data as infill lines, and also the drilling feasibility study of the onshore part. Ladies and gentlemen, the area has quite a high potential given the good reservoir properties as presented to you. The hydrocarbons bearing reservoirs, as you saw, H15 and H25, but also the proximity of this field, of this block, to the already major discoveries in the nearby northern part. Ladies and gentlemen, the Kasroban contractor area here presents a farm down opportunity where we are looking for a joint venture with whom we can invest in future exploration activities in order to further refine the potential of this block. I thank you.
Good morning. The primary goal of my presentation is to integrate various geophysical data because the area we're working in, Block 14T, is very tricky. So we have to bring various geophysical data on board so that we are able to locate our resources. So the objective of my study was to locate the presence of depot centers within my area of study. I can't see my slides. So the objective was to locate the presence and depth of burial of depot centers within my area of study, which is Block 14T. Block 14T is on the southern part of the Kenyan Tertiary Rift. It borders Tanzania, Lake Natron. The second objective is to determine the presence and the orientation of the faults. And of course, I'm going to integrate gravity, magnetic, and magnetotelluric data, the MT data, with seismic section in trying to map the resources. So Magadi Trough in the Kenyan Tertiary Rift Basin hold the promise of substantial hydrocarbon reserves, because it has been discovered in the northern part of that basin, in the Lokichar basin. So basically, there's high possibility that it can also be discovered here in Block 14T. An FTG survey was carried out some time back to try to map out the distribution of sediments within this block. And FTG did a good job in mapping out areas of interest, low anomaly regions where sediments have accumulated. From the FTG, we had a seismic survey that came after the FTG. And as you all understand, that area is covered by volcanic beds, volcanic layers. So the quality of seismic registered is not very good. It's fairly good, but not good enough to make good interpretations. And that's the reason as to why we ought to bring various geophysical methods on board to try to unravel that problem. Ground gravity data and seismic were also done. Ground gravity and seismic are good because they give us high resolution grids, so that we're able to get subtle images, subtle changes in the geological properties of the ground. And because of this problem of, as somebody said yesterday, the volcanic layer, we had to use an MT so that we are able to map below the volcanics, because the sediments are said to be below the volcanics. Next. This map shows an FTG grid, and on it still we have about 9 lines of seismic lines that were conducted in that area some time back. Some are running from east to west, and 3 of the lines are running from north to south. If you look on line 1, as captured on the seismic, some of the areas they've got very good reflections. But as you move towards the east, it becomes a little bit chaotic. There's discontinuity of seismic reflections in some of the sections from the seismic. Hence, there's need to deploy various geophysical methods to try to understand this area. Next. Here, This shows modeling of gravity and mag data. You take gravity and magnetic data and try to get how the signals are behaving. This, for this particular profile, running from north to south, we got that kind of model. The whole idea, the science here is to try to understand where we have got maximum accommodation space. The green there, essentially, our basement. And then the top, on top of it, we have got some sediments. And then the yellow there, we have young, extremely young sediments, plus the blue ones. So basically, the whole idea here is to get where do we have the maximum accommodation space, where sediments could be located for this particular profile. Next. The ground gravity survey also gave us 3 areas of interest. Ground gravity has got higher resolution than FTG. FTG could not resolve those 3 depot centers, but we were able to get them from the Simbo-Boge anomaly grid, and even the MT we did agrees with what we are seeing on Simbo-Boge grid. Next. As it has been said by one of our presenters yesterday, we can see clearly that we have some recent sediments which are bluish in nature on the top of that section, and below that we've got the reds, which represents our volcanic flow, and then below that we have got some areas of interest. We have low resistive layers. So, MT has got slightly lower resolution than seismic, but here MT has done a good job in terms of trying to give us where the thickness of that, the thickness of the volcanic, and then trying to map the way this basin is in terms of even the basement, the geology of the basement. And then you can also be able to identify a few faults on this section. So MT must be used together with other geophysical methods in order for one to make an informed decision. Next. This basically represents a 3D of one of the empty lines that was acquired in this area. From the top, 1.2 kilometers up to 6.9 kilometers. Because a geologist might want to know how does the basin behave. If you look at that, well, we have some blue anomalies. There are those which are vanishing as you go down, and then there are those from about 3.7 kilometers that are becoming more pronounced. And then we have the reds. The reds in that image represents the high resistive, basically volcanics in that area. Next. So basically, within the area of study, the sediment packages of interest are buried at a depth of roughly about 3 kilometers. Sadly enough, these sediments lie below the volcanic layer, and this, as I've said, is a complex problem. And then Simbo-Boge was able to give us 3 depot centers, one in the north, in the middle, and one in the south. And then I would say that the top basalt is the probable seal recognized from the MT studies. And finally, the seismic gravity interpretation shows a fault pattern that's likely to be the trapping mechanism. Thank you so much.
Thank you. Can we take up the fourth presentation for the session? Just hold your questions. We will have questions at the end of the session. Our presenter is Cindy Maduhu.
Good morning. As I have been introduced by the moderator, I'm Cindy Maduhu from TPDC. I'm going to present about the architecture of the EAPCE'25 Rift. As you know, this is a frontier basin in terms of exploration. TPDC have done a lot on other basins along the East African Rift system, but the EAPCE'25 started exploration in 2015. So we had a lot to do in order that we can at least know what is within the basin. Yeah, these are my objectives where we are going to base on our discussion today. And when we say EAPCE'25, this is the basin, Rift Basin, which is along the East African Rift system, on the eastern arm of the East African Rift system. And also it is at the extreme end, near to the Tanzania divergence zone, where the rift separates into three compartments. This falls on like 5 regions in Tanzania, as it is displayed there. But also this block is about approximately 5.7 square kilometer. When we talk of EAPCE'25, it was extended up to Natron. We started exploration in 2015 in order at least to get the area for concentration. So we decided to do airborne gravity gradiometry survey in the area in order that we can at least understand the nature of the basin, but also approximate depth of this basin and some compartments within the basin. And the main objective is to explore oil or gas in the area. Due to the nature of the area, it is somehow complex because it doesn't have any exposure of rocks except on the western part of the area where we can just see the basement and meta sediments. But most of the area is a plain area. As you see there in the yellow color is the basin itself, but there is no any exposure of the rocks. Therefore, we are supposed to do some of the works in order that we can at least know what is the thickness of sediment, delineation of the basement configuration, but also defining the structural framework of the main bounding fault and identify intrabasinal faults crossing, liaison, and other structures within the basin. Also, in order to know at least the potential structures influencing search for oil in the area. Next. Here, as I said, we started exploration in the area in 2015, where, as you see, those blue lines are the airborne gravity gradiometry survey, which was surveyed in 2015-16, where the separation of this survey was 1,000 kilometers from one line to another, and tie line of 2 kilometers. But the drape height was 80 meters from the surface. So we did it and we tried to do interpretation of the data. And then afterward, we decided to do borehole. We drilled 3 stratigraphic borehole in order to understand the geology And our intention was to drill on the margin of the basin so that we can at least encounter all the stratigraph. Fortunately enough, we didn't, and each of the borehole were supposed to go beyond 300 meter. But anyway, we got some of the information. As geologists say that the present is the key to the past, and we identified some of the sediment so that we can at least project on what is within the basin. Thereafter, we decided to do amplified geochemical imaging in order at least to know or to confirm if there is any indication of hydrocarbon within the basin. And the method was very successful, but also, as Musa explained about the microseepage analysis using satellite information, we were in a position to make sure that this area is potential for TPDC to proceed with exploration. And it decided to sponsor it 100% using our own fund to make sure that at least we go ahead with exploration. Therefore, we decided to put some pilot lines, like 260 line kilometer of lines. As you see, red lines on the map, those are the seismic lines, and we decided to put it across the main bounding faults, and some of them we decided to put them along the bounding faults. One is at the dipole center of the basin. So in this study, it concentrates much on potential field interpretation and also seismic interpretation. And these are the results where we did it and got most of the structures. As you see, on the western part of the area, most of the structures runs southeast, northwest. But when you go toward the eastern part, at the central part of the area, most of these structures runs northeast, southwest. When you go further to the extreme end of this area, the faults turns and goes or orients on the northeast part, northeast, especially on the left part of Manyara and Natron, the structures runs northeast. There are some bounding faults. We have also some relations which separate some of the compartment of the basin. But there is a suture zone which also indicates different type of geology. We have Archean, but also Proterozoic belt on the eastern part. But most of this area is covered by volcanoclastic sediment. It means that the sediment which forms the basin comes from the clastic part, but also comes from the volcanic activities from Ngorongoro and other areas. So that's why we call it volcanoclastic sediment. When we did, next, we tried to see where we can concentrate regarding the depth of sediment within the basin. And when we, as you see on the map, we have like 3,000 meter deep of sediment. But when you go back, when you go back, it seems that on the western part of the area, we have deeper sediment. But when we did analysis, we saw that like the best area to concentrate is on the western part. But due to this pilot study of seismic data, we encountered some areas of shallow basement on the western part of the area. But on the eastern part of the area, it seems that the sediment package increasing toward the east. So we decided to concentrate on the eastern part. And these are the result of seismic data, where we have postulated most of the lines of the horizon and also faults. These are the set of faults within the basin, and it seems that the bounding fault is nearly vertical. I think the event happened abruptly, and then some of the sediments were deposited in the basin.
Between the Neoproterozoic and the recent sediments. So for us to know what is really buried in the subsurface, and also isolating the regional anomalies, we must disintegrate the data. So the next plot is of my survey station, mainly spaced around 300 meters by 300 meters. And the other grid is the Boga anomaly grid. The Boga anomaly grid has both the regional and the residual anomaly combined together. So, like I had mentioned before, you can go ahead and interpret the grid as how it is. But for proper interpretation and understanding of the localized resources, then you should isolate the grid. So the methodology is the application of filters. I know the filters are readily available in most of the softwares, but since I was doing the project using GeoSoft, so that's why the filters have been picked from the GeoSoft. But if you are using the softwares like Safa, it's still okay, because the filters are universal. So I will demonstrate starting from the nonlinear filters, polynomial trend, then upward continuation, low-pass filters, and high-pass filters. The filters are so many, so I've not covered them all. There's band-pass filters, vertical derivatives. So I've not talked about them all, but I've picked a few just for the sake of demonstrating. So like when you're applying the nonlinear filter, one thing you must keep in mind is that filters can as well represent a misinformation. So for you to be guided is that you need to note down the distance between the points to avoid aliasing, which necessarily means that when you insert or use the unnecessary parameters, you will end up with a grid, of course, which will be of a misinterpretation or misrepresentation of the subsurface. The next one is upward continuation. When you apply filters like upward continuation to a depth of around 4,000 to 6,000 meters below the subsurface, you will be necessarily enhancing regional anomalies. Now, after getting the regional anomalies, you do what we call the grid subtractions, where you end up with a residual anomaly. So, as you can witness, there's a residual anomaly on the top, then below it, there is a corresponding regional anomaly. So when you're dealing with the polynomial trend, you look at the degree of order. Of course, polynomial trend only enhances the regional anomalies. So like I mentioned before, on the upward continuation, you do the grid subtraction to come up with the residual anomaly. Low pass filter only enhances the widespread deep-seated materials, like the regional anomalies. So for you to end up with a residual anomaly, you need to do another grid subtraction to come up with a residual anomaly. The last, which is the high-pass filters, it enhances the residual anomaly. So when you're applying the high-pass filters, you only end up with a residual anomaly. To get the regional anomaly, you must do the grid subtraction to come up with the regional anomalies. So the conclusion is that Boga anomaly requires to be disintegrated for proper interpretation. And also, what I realized during the process is that nonlinear filter scheme is reliable for gravity data decomposition because it is easy to determine its cutoff length by just doing the visual inspection. And also what you should note is that no scheme or no filter is better than the other. Because most of the time, the filters are subjective. So it is now upon you comparing what you observe on the surface or the regional geology and the local geology and what you see in the results that you get from each filters. So the business opportunity is that when you apply the filters, you are reducing the uncertainties, hence you are enhancing exploration success. Another business opportunity is that the National Oil Corporation of Kenya have built up a team of geoscientists who are mandated to handle data processing and interpretation. Hence, we can work together so that we can explore our resources. The last is expansion into underexplored basins. Some basins are underexplored, like the Magadi Basin. Reason being is because of the complexity of the area. And you know, it is very easy to acquire a gravity data, which you can use to get your results and make an informative interpretation. Thank you.
Thank you. We can use this time now to ask questions or comments or compliments. So it's time for the audience to talk to the panel, to the presenters, and if you've got specific question, you can direct it to the specific presenter. Karibu.
Thank you. Good morning once again. I am Dennis Mosh from University of Dodoma, geology student. My question goes directly to Mr. over there. I want to ask the question that you said that you performed an MT survey, magnitudic survey, to study the sediment that were overlaid by volcanic materials, right? Yes. Now, the question is, were those sediments altered or were not altered? And if maybe they were altered, can you briefly tell me how was the MT response on them? And the last question is that, how did you manage to solve the problem of the static shift in the MT survey? Because we know that this crust is not homogeneous, meaning that it is composed of different composition in the subsurface. Now, how did you manage to to solve the issue of the static shift problem, which is crucial to the whole practice of the MT magnetic survey. Thank you very much.
Another question? Yes.
Thank you. I have two questions for my friend Cindy. You illustrated very well how you interpreted the seismic and looked well on the near surface, but as you are going down, we're seeing uncertainties on discontinuity of the reflections. However, you've interpreted the epoch horizons. My question is, what did you use for certainty to establish that this is a Miocene horizon, this is a Pleistocene? So, because I don't know if you have a well there, and so you don't have a well, which that's what I know, and so I don't know how you got the samples you used to be able to ascertain that, you know, this horizon you're mapping is this is Miocene or is early or mid? Because it looks like you have a lot of uncertainties in that. Number two, do you have any geochemical surface mapping that has been done in the basin? Because you didn't mention anything on any exposed outcrops. And if yes, were there any results on maybe on the TOC that you've got? Because those are the questions that any strategic partner will begin to ask. Yes, you say there are reservoirs, but do we have any evidence of source rock? Yeah.
Another question or comment? Yes, please.
Thank you, dear presenters. Good morning to everyone. My name is Susan Viona and I'm from Uganda. I would like to commend all our dear presenters for the wonderful presentations. I've really enjoyed them. My question is directed to Innocent. I would like to know the densities that you used for modeling, coming up with your models and the software that you used. And I don't know how many layers are in your model. Thank you.
There was a question there.
Okay. Thank you. My name is Abdul Makishe. My background is on geophysics. I am with Pura. My question is directed to Mr. Joshua. You presented on the Magadi Basin, which is just north of Lake Natron in Tanzania. Actually, I was wondering on which is the best method used on the filters, that is the non-linear or upward continuation, to be able to estimate the whatever depth which you probably think is the depth of the sediments. And the second question is, do you have any other data like seismic or well boreholes which will give you some feel of the depth of that sediments, the sediments which can actually verify the accuracy of the Bouguer anomalies? Thank you.
Okay, let's take the last. Was there any other question from? Yes.
Thank you. Good morning. My name is Dr. Meshak Kagia, board committee member from Pura. My question goes to Musa Nalogwa. Yeah. Yes, about the micro seepage. Have you considered to undertake a geochemical analysis, or I mean to complement or to supplement this micro seepage by taking sampling of the areas where they are indicated to have seepage? Because I'm doubting that maybe the bleaching of the either from ferric to ferrous may be due to change of acidity, yeah, due to the maybe meteoric water seepages and things like that. Yeah. And I don't know if is it the same with Mr. Maduhu with this geochemical imaging, is it the same as geochemical analysis? Okay, that is my question. Thank you.
Thank you for the good question, Dr. Kagia. There was two possibilities thought about before. We thought about doing the radiometric, but then it came the AGI, as you said. This area is within the EAPCE'25 basin as well. It's just a part of the area who was being studied. So then when it came to the AGI analysis, they took samples to for the same, I mean to ascertain the same by measuring the hydrocarbon.
So the question is asking about how to correct for static shift. We did a TDM, a TEM survey. Every station we did an MT. So the time domain survey we normally do at every station. So whether the sediments were altered or not, MT cannot differentiate that. It just gets the bulk properties. It doesn't give us whether they're altered or not. It cannot give those specifics. There's somebody who asked me about the sediments and the trachytes and the basement, about the density and susceptibility. Sediments have got low density. I use about 2.2, and low susceptibility of about 10. Trachytes will have high susceptibility of about 4,000, with slightly higher density of 2.5. The basement will have slightly higher density than that of about 2.67 and susceptibility of about 2,780. Thank you.
Okay, I have two questions. The first one is, what did we use to ascertain the horizon? Yeah, as you know, this is the frontier area. There is no any drilled well. And as I said, there is no any outcrop which is exposed. The only method which used was to the analog basins. We used the open source analog basins data in order to postulate the horizon. That is the method we used in order to make sure that at least we get some information regarding the horizon. The second one is energy geochemical. Yes, we did amplified geochemical imaging is the method which was used. It is like you bury an absorbent in the ground at a certain depth. We distributed like 1,034 sampling points where we just distributed them regarding the previous data which we acquired, the magnetic data, but also we integrated with the plan of the seismic lines in order that we can understand exactly where we can just get the feel of the geochemistry. It has given us a very good result, because when you see them, the result is along the bounding fault. The seismic line, as you have seen, most, if you take on the the line which is along the bounding fault, most of the faults are buried. At the top we have volcanoclastic sediment, which I think they have very low porosity also. Therefore, it is not easy for the hydrocarbon to migrate from the subsurface to the surface, except on some of the rifts. So it marked a very good result, and the TOC is about, there is oil window, but also there is gas window. Thank you.
Yes, the last one.
I have two questions concerning depth of sediments. The presentation was a 2D grid. So with that, you cannot tell of the depth of the sediment. But if you want to know the depth of the sediments, you can build a 3D grid using those grids to estimate the depth of the sediments. The 2D grid only represented SAGs, or low density areas. The next question was about seismic data available in the area. Yes, we have seismic data available in the area. We also have MT data, magnetic data available in the area. So you are free to come and talk with the corporation if you want access of those data.
Thank you. I know that there would be a lot more questions to the presenters, but they will be available. It's tea time. We have to move to the next session. I'm told that there's presents which are supposed to be given to the presenters. And then we will have a group photo for the presenters. Otherwise, before we go for the group photo, let me thank you very much presenters, for the good presentation on the East African rifts. And the basins are available, business opportunities are available. So let's work towards enhancing the availability of opportunities within the East African rift basins. Thank you very much. Let's have a group photo, and then it's time for tea. And during tea, after tea, we go straight to the next parallel sessions.